ladies and gentlemen. Today we're going to deal with Lewis dot step by step. These directions for Lewis dot structures are in your homework packet. I think it's page 3. And I always sort of follow these steps when I draw a Lewis structure. So I wanted to kind of go over a few of them so that you could have kind of an idea before we get rolling. Now, number 1, these are all going to be for substances that are covalent. So I'm going to write over this. 1, if something is covalent, the electrons are being shared. Okay, this is kind of like if we go to a party, okay, and we all bring our electrons, and you might bring 2, and somebody else might bring 7. What we would do is we would take all our electrons and throw them in a big cup, and at the end of the night we would take everything out of the cup and make sure everybody had 8 electrons. That is what we are going to do. We are going to share electrons. All right. So, ladies and gentlemen, this only happens with covalent. We're going to start with an example problem, CF4, okay? And then if we look over at the actual steps, it says, count the total number of valence electrons in the molecule. So we have C, F, and 4. So we would take out our periodic tables, and we would look at carbon. Right there, carbon is in group 14, so it has 4 valence electrons, 4. And then fluorine, we would look right here. Fluorine it's in group 17, 7 valence electrons. And it's not just one fluorine, there are 4 of them. So if we add all that up, our total number of valence electrons would be 32 valence electrons. It's a lot of valence electrons. We've now taken all of our valence electrons and put them in this nice little cup, and now we're going to shake it all out and see what happens when we draw them. All right. So now if we look at the rules, rule number 2 is arrange atoms around carbon or the least, that's supposed to be electronegative, atom that's not hydrogen. So I'm going to put carbon here in the middle, and I'm going to put fluorines around it. 1, 2, 3, 4. Very simple. I've just drawn. It's awesome. Easy breezy. Okay? Now it says connect each adjacent atom with an electron pair. So I'm going to put a pair of electrons here, okay, for each atom. All right, so now step 4 said add unshared electrons so each atom has an octet. There will be some exceptions, hydrogen, beryllium, and boron. Well, we don't have to worry about those. We don't have any exceptions. But let's take a look at carbon. Does carbon already have an octet? I'm going to use some sticky notes to kind of hide these things. But if we get rid of the F's here, does carbon have 8 electrons around it? You know what? To me, it looks like it does. So carbon's cool, but let's look at this fluorine. How many electrons does this fluorine have around it? Right now it only has 2. It wants 8, so we're going to put 8. And we're just going to make sure it has 8. And we're going to do the same thing for each fluorine, okay? This fluorine only has 2, so we make sure it has 8. Because an octet is what every atom wants. This one only has 2, so we make sure it has 8. Okay? And this one only has 2, so we make sure it has 8. So ladies and gentlemen, there's the Lewis structure. Now let's see, we're not quite done. It says 5, count the dots. So I'm going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 dots. Sweet. If the number of dots equals the number of valence electrons, you're finished. Guess what? I'm finished. Sweet, I've just drawn the Lewis structure for CF4. And that's what I'm going to expect you to do. This is the Lewis structure. And then we have something that we call the structural formula. This one is just kind of a shortcut, and you can do this pretty simple. You put C in the middle, and instead of 2 dots for a bond, you draw a line. And so the line equals 2 electrons. So we've done that. However, unbonded electrons need to still be drawn in. So here's what it would look like structurally. Okay? And this is how you would draw a structural formula for this compound. All right, so we've done one, CF4. Let's try another one. All right, new piece of paper. I know, so exciting. You can't even believe that you're spending your evening watching this. You're so pumped up. Let's try NH3. All right, NH3. First step, count the total number of valence electrons in the molecule. So I look up nitrogen, and I'm going to go to my periodic table. Nitrogen has 5 valence electrons, so 5 valence. And then I'm going to add that to hydrogen. Hydrogen's all the way on the other side of the PT over here. It has one valence electron. But there's not just one of them, there are 3. So if I do the math, it comes out to 8 valence electrons. Cool. All right, so now we can go to step 2. Arrange atoms around carbon or the least negative atom that's not hydrogen. Oops, the bell rang. It's now 6B, just in case you wanted to know. All right, so I'm going to put nitrogen in the middle, and then I'm going to put my hydrogens around. Okay? It says connect each adjacent atom with an electron pair. So I'm going to connect. There's my pair. Cool. Then number 4 says add unshared electrons so each atom has an octet. So we're taking a look at nitrogen now, and we are taking a look here. It seems as if nitrogen only has 6, so it needs to have 8. That's cool. We're good. Now I want to look at hydrogen. Hydrogen only has 2, but look at this. There are some exceptions. Those exceptions include hydrogen. It only wants 2. Is that cool then? Sure is. This hydrogen is cool. This hydrogen's cool. We're all great. But, oh man, the next step is count the dots. 2, 4, 6, 8. 8 dots. Are we good to go? Oh, I think we are. Okay, so that's your Lewis structure, Lewis. And if I were to call this a structural formula, I would do the lines for each bond. And then this lone pair would be showing right there. So there you go for NH3. Let's do one more that maybe, just maybe, doesn't work out so perfectly. All right, so we're going to try, how about just nitrogen? Nitrogen, the diatomic molecule, N2, okay? Well, we already decided nitrogen brings 5 valence electrons. Okay, cool, and there are 2 of them. So at the end, we need to have 10 valence electrons. Awesome. So now, arrange atoms around carbon. Well, we don't have a carbon. We just have 2 nitrogens, so we're just going to put the 2 nitrogens next to each other. Cool, okay? Now, the first thing I'm going to do is I'm going to connect each with an electron pair. So I have my pair. Awesome. And then it says add unshared so each one has an octet because that's the goal. And nitrogen doesn't have any exceptions. It just wants 8. So now they both have 8. We're good to go. Cool. Now let's see here. 2, 4, 6, 8, 10, 12, 14. 14 dots. Ladies and gentlemen, 14 dots is not cool. We've got to do something about that. If the number of dots does not equal the number of valence electrons, it says redraw the atoms. So I'm going to redraw the atoms. And that says add a second electron pair between each atom. This is called a double bond. So now, then, once we've done that, we have to go to step 5. Okay, it should be go to step 4. We want to make each one have an octet. This nitrogen has 4, 5, 6, 7, 8. Now this one has 4, 5, 6, 7, 8. Cool. Excuse me. All right, now let's count the dots. 2, 4, 6, 8, 10, 12, 12 dots. Woohoo! All right, still not cool. We need 10 dots. Oh, guess what? Let's redo it again. I'm going to put this up. Now, I'm going to draw an N, and instead of a double bond, we're going to call it a triple bond. Beautiful. And I take this nitrogen right here. Now that has 8. This nitrogen already has 6. Now it has 8. And we count the dots. 2, 4, 6, 8, 10 dots. Holy moly, that's beautiful. And guess what? 5 of them come from one nitrogen, the other 5 come from the other, and we have a beautiful Lewis structure that works out. And then if I'm going to draw the structural formula, it would look like this. All right, sweet. So that is my short 9-minute video on Lewis dot structures. Is there more? Absolutely. Are there exceptions? All the time. Different rules have different things going on, but we're going to get to that later. So hopefully we can get you through this process and you can start practicing. Have a good night. Bye.